integral of 5x e to the negative x squared dx. So we're going to take u equals negative x squared, and then du equals negative 2x dx. So I'm going to rewrite this integral and see if it works using u substitution. E to the negative x squared times 5x dx. So everything's perfect except for that 5, so we need to undo the 5 and replace it with negative 2. So if I multiply by negative 2/5 on the inside of the integral, we'll multiply by negative 5/2 on the outside. That gives us negative 5/2 times the integral. Those 5's are going to cancel out, and we'll have e to the u du. And the integral of e to the u du is e to the u. So we'll have negative 5/2 times e raised to the negative x squared power plus c. Okay, here's for you to try. And the answer is 2e to the x squared plus c. We have two rules for logarithmic functions. They are the integral of 1 over x dx is equal to the natural log of the absolute value of x plus c. Now the reason why we have the absolute value of x is because the argument of a logarithm must be positive. So whereas I can have a negative value in a denominator, so I can have a negative value in the denominator, I cannot have a negative value in the argument. Therefore, we're going to use those absolute value symbols. And likewise, if we have a little bit more complicated of a denominator, we'll have the integral of 1 over u du using u substitution. And again, we'll have to keep that argument positive. Therefore, we'll have the natural log of the absolute value of u. The natural log of the absolute value of u plus c, yes. Okay. So let's do a few of those. We have example 4, the integral of 4 over x dx. Well, I'm going to rewrite this. So I'll rewrite. Before I do u substitution, I can recognize that if I take the 4 to the outside, then I don't have to use u substitution because that denominator is just x. And what's left over is perfect, it's just dx. So the integral of 1 over x dx is going to be the natural log of the absolute value of x. So we get 4 times the natural log of the absolute value of x plus c. Okay, in this next example, a little bit different. We've got 1 over x squared, and 1 over x squared could be 1 over u. So let's see if that works. If we let u equal x squared, then indeed du is going to equal 2x dx, because the derivative of x squared, remember, is 2x multiplied by that differential dx. So we can rewrite this using u substitution. We have 1 over u times du, which is the natural log of the absolute value of x squared plus c. But do we really need that absolute value? So this is going to come up every once in a while. If the argument is going to naturally work out to be positive, you do not need the absolute value. There will become parentheses. I like to write the argument using parentheses, so I just change the absolute value to parentheses. Okay, and one more example, and then we're going to let you do 3 tries. So here we have the integral of 3 over 3x plus 1 dx. Hopefully you're getting used to seeing what you think u is going to equal, and then doing that derivative in your head mentally and seeing that that's very close not 3x, 3 dx. That's very close to what's going to be left over. In this case, it's exactly what's left over. We've got the integral of 1 over 3x plus 1 times 3 dx. So that's the integral of 1 over u du. So we're going to have as an answer the natural log of 3x plus 1. That requires absolute value plus c. Okay, there's 3 for you to try. You can try one at a time and press play to reveal the answer. Make sure that you're getting it before you move on to the next. Or if you're feeling very confident, you can try all 3. Just be careful that you're not feeling too confident and then perhaps practicing the wrong technique and then reinforcing an incorrect process. So I got for an answer 2 times the natural log of the absolute value of x plus c. And the next one, I got 3 times the natural log of the absolute value of x plus c. We could also say the natural log of the absolute value, that looks like an I, the natural log of the absolute value of x cubed plus c. Either one of those would work. We would need the absolute value in either case though, because a number times itself 3 times could still be negative. And then this last one, the natural log of the absolute value of 2x plus 1 plus c. So I'll bubble all of those so that you can see the answers. You might be thinking, can I write the natural log of x squared plus c? You could, because we know those are the same thing. Okay, example number 5, the integral of 1 over 2x minus 1 dx. So here is where our u substitution requires us to be a little bit more creative with our constants. So du is equal to 2 dx, but you can see that we don't have that 2 dx, we only have 1 dx. So we'll have to rewrite this as the integral of 1 over 2x minus 1. And then we have that dx, but we need 2 dx. So we multiply the inside by 2, the outside of the integral by 1/2. We get 1/2 times the natural log of the absolute value of 2x minus 1 plus c. Okay, there's one for you to try, and I'll come back with the answer. So if you got 1/4 times the natural log of the absolute value of 4x plus 1 plus c, you're catching on. Okay, one more example and try for this video. We've got example number 6, the integral of 6x over x squared plus 1 dx. So we're going to let u equal x squared plus 1. We will let du equal 2x dx because that's what the derivative of x squared plus 1 is. We have the integral of 1 over, got a dog barking out there, 1 over x squared plus 1 and then we have times 6x dx, but we need that to be a 2, not a 6. So we're going to undo the 6 by dividing by 6, and we're going to replace it with a 2. So if we multiply the inside by 2 6, we have to multiply the outside by 6/2. And 6/2 is 3, so we have 3 times the integral of 1 over u. The 6's cancel out, and 2x dx is du. So 3 times the natural log of u, and the natural log of u would be the natural log of x squared plus 1. Notice how I'm using parentheses here. That's because no matter what x is, we're going to multiply it by itself. It will become positive, and then adding 1 will keep it positive. Therefore, this is a great example of not having to use absolute values and being able to replace them with parentheses. Okay, go ahead and try the next one. I'm going to show my work quietly. So hopefully you got that answer, 3/2 times the natural log of x squared plus 4 plus c. Again, no need for the absolute value because the plus 4 will keep that x squared positive.